by what angle does a tower now deviate from the vertical. So at the beginning, say the tower is on this ground, so it's perfectly fine. So this tower is perpendicular to the ground, and let's call the tower T. So this vector is perpendicular to the ground, and say here's ground. And after that, the tower, everything, the tower, the ground get tilted so that the measurements of 3 points on the ground changed. So say this now become, for example, it's got tilted like this, and we would need to compute the angle of the tower with respect to the vertical direction. Let's call this the vector k. So correspond to, we have I, j, k. K is a vector 0, 0, 1. So we would want to know what is the angle theta between t and k. So the goal is compute the angle theta between t and k. So we don't know the vector t directly, but we do know 3 points on the ground. So A, B, and C. A, B, and C. We know that the cross product of AB cross AC will be parallel to T, right? Because AB cross AC is perpendicular to the ground. So AB and AC. Vector AB cross AC. Note that vector AB cross AC is perpendicular to both AB and AC, so it is perpendicular to the ground. So AB and AC have the same direction with T. Is parallel to vector T, vector tower. But we don't know that whether B is really here or C is here, or maybe B here, C there. So depending on the position of B and C, the vector AB cross AC might be so pointing up there or pointing down. We do not know from this picture. If we draw it like carefully on the XYZ coordinates, we would know it's point up or down. But in this case, we don't need that. We can still compute theta. So let's say this is AB, and AC. AB, AC, and the tower in this direction, vector tower, and this is a vertical line, vector k. This is the angle theta we need to compute. So we know that AB cross AC is in the same direction as T. So either depending on the position of B and C, so AB cross AC either pointing up there or pointing down. So either AB cross AC is either n, let's call it vector n, or n prime. So note that AB cross AC, depending on the position of B and C, is either n or n prime. So n and n prime actually have the same length. Length of n and length of n prime are equal. They are only different in the direction, pointing up or down. But either way, the angle between n and n prime with respect to the vertical line is the same. So this angle and this angle, these two angles are the same. So either way, the angle is theta. The angle between the tower and K and the vertical direction is theta. Okay, an acute angle less than pi by 2. Okay, so now we have the suppose AB cross AC is n, the angle is theta. If AB cross AC is n prime, the angle between AB cross AC n prime and K is, say this angle is pi minus theta. So cosine of pi minus theta is the same as minus cosine of theta. So they have the same absolute value. So we know that cosine of this angle is, absolute value of cosine of this angle is the same as absolute value of theta. So now we have AB cross AC dot product with K. We know that by the properties of dot product, this is the length of the first vector times the length of second vector times the cosine of the angle between them. Let's say cosine alpha, let's call it alpha, and we know that alpha is either theta or pi minus theta. So the angle between AB cross AC either this n or n prime, and cosine alpha the angle between n and k, or n prime and k. So it is either theta or pi plus theta. So in any case, then absolute value of cosine of theta is the same as absolute value of cosine of pi minus theta. So from this formula, we can compute absolute value of cosine alpha. So which is absolute value of cosine alpha, which is by formula, say star by star, this is absolute value of this dot product divided by this number. So AB cross AC, this is positive, length of K is positive. So from the 3 points we have these 3 points A, B and C. We know vector AB, we can compute vector AB and vector AC. AB is vector 2, 2, 0 and AC is vector 0, 1, 3. And then we compute the dot product AB, we compute the cross product AB cross AC. So by some computation, what we have should be 6 minus 6, 2. Okay. And K is vector 0, 0, 1. Right, so we call K is vector 0, 0, 1. So absolute value of cosine of alpha is the dot product of the two. So dot product of absolute value of 6 minus 6, 2, 0, 0, 1 divided by the length of 6 minus 6, 2 times the length 0, 0, 1, which is 1. Okay, so this one gives us 6, 6, 2. So it's so the denominator is 2, denominator is square root 6, 6. So 36 times 2 plus 4 times 1, square root of 1. So 2 square root of 76. So that cosine of alpha, which is cosine of theta, as theta is acute. So theta is r cosine 2 square root 76. So that is the angle we need to compute.